Hello everybody, welcome. Okay, so we are in our fourth module. We are studying about the dynamics, kinematics and kinetics of rectilinear and curvilinear motion. Okay, we have completed the first part, that is the kinematics of rectilinear motion. Kinematics of bodies subjected to rectilinear motion. That was what we studied in our first part. So, having a small introduction, we saw what is dynamics. So, dynamics is the study of the mechanics of objects or bodies subjected to motion. And if the forces responsible for the motion is not considered, the study is called kinematics, and the mechanics of the motion of bodies subjected, that is the motion, that is the forces responsible for causing the motion is also considered. We will call the mechanics as kinematics. So as I told you in the previous classes, we have in the fourth module we have to study kinematics of rectilinear motion, kinetics of rectilinear motion, kinematics of curvilinear motion and kinetics of curvilinear motion. Okay, so we have already completed kinematics of rectilinear translation. So for kinematics we saw kinematics is nothing but it is used to define the geometry of motion, that is the displacement, velocity and acceleration. So we used these equations of motion for kinematics to solve the problems. Now the second part is kinetics of rectilinear motion. So forces are also considered. Kinetics is nothing but relating the forces, relating the external and the internal forces, that is kinetics. Kinematics is relating the geometry of motion. Kinetics is relating the forces. Okay, going for a small look into our syllabus. We have already seen this. So our syllabus is about dynamics, rectilinear motion and curvilinear translation. So this is what we have already studied in our first two videos: dynamics, rectilineer motion and equations of kinematics. And using these equations of kinematics, we solved some problems. We solved some 10 problems to find the geometry of the motion, to find the velocity, acceleration, distances, etc. Now, we are going to study the second part, that is kinetics of rectilinear motion. We are going to study the equation of motion for kinematics, D'Alembert's principle. D'Alembert's principle is the equation of motion for kinematics. So using D'Alembert's principles, we have to find the motion on horizontal and inclined surfaces and the motion of connected bodies. So in the second part, we are going to study the kinematics, that is the relationship between the forces using the equation of motion for kinematics, that is nothing but Newton's second law. Then the extension of Newton's second law is D'Alembert's principle. Application of D'Alembert's principle. Using D'Alembert's principle, we will find the motion of bodies on horizontal surface, inclined surface, and when two or more bodies are connected. Okay, we are going to our second part, kinematics of rectilinear motion. Okay, so first is the law of motion, kinetics law of motion. This is called the kinetic law of motion, Newton's second law of motion, because this law relates the relationship between the forces, internal force and the external force. So Newton's second law, by definition, it is nothing but the rate of change of momentum of a body, and it is directly proportional to the resultant force. That is, the resultant force is a sigma F. So F is equal to mass into acceleration. Sigma F is equal to mass into acceleration. As I told you earlier, this is the relationship between forces. Sigma F is the external force, mass into acceleration is the internal forces. So summation of external force is equal to internal forces, that is nothing but the change of momentum, rate of change of momentum of a body. So sigma F is the summation of forces in the direction of motion. We will have two directions normally, x direction and y direction. So both the direction, sigma F is the summation of forces in the y direction, while resolving horizontally, sigma F will be the summation of forces in the x direction. M is the mass of the system, which is expressed in kilograms, always expressed in kilograms. And A is the acceleration of the system in the direction of motion, meter per second square. So, if this sigma F is acting in one direction, MA will act in the opposite direction. That is why it is a sigma F is equal to MA. Now, D'Alembert's principle. So, this is an extension or some application of Newton's second law of motion. Okay, so D'Alembert's principle is the application of Newton's second law, and it states that the system of forces acting on a body in motion is in dynamic equilibrium with the inertia force of the body. So, the system of forces acting on a body in motion, that is, see, we know how to draw the free body diagram and what are the forces that will be acting on the body. We know all the external forces. When a body is in motion, what are the external forces that will be acting on the body? The normal force, the frictional force, etc. Now, these forces together is called the system of forces acting on a body in motion. And if this forces is in dynamic equilibrium, it will be in equilibrium with the inertia force of the body. Inertia force is nothing but mass into acceleration. So, this is Newton's second law, sigma F is equal to mass into acceleration. So, sigma F minus MA is equal to 0. So, sigma F is the external force, Fi is the internal force, that is nothing but the inertial force, forces of inertia, mass into acceleration, that is equal to 0. So, this force, this inertia force acts in the direction opposite to the direction of the external force. If external forces are acting in one direction, the internal force is acting in the other direction. In symbol we can say that. See, we know if the external force is acting in one direction, that is acting in the direction of motion, the frictional force will act in the opposite direction. So, this inertia force will act in direction equivalent to the frictional force. Inertia force will act in the opposite direction of motion. So, sum of net force and inertial force is equal to 0. Now, inertia force acts in the direction opposite to that of the motion. And similar to statics equilibrium conditions. Now, by applying this equation, our dynamic problem becomes a static problem. Our dynamic condition is converted to a static condition. So, once we have arrived the equivalent static condition, we can easily solve the problem by resolving the forces in horizontal and vertical directions. Now, D'Alembert's principle is used to convert the dynamic problem into a static problem. Okay. So, the equation of motion is nothing but Newton's second law, and D'Alembert's principle is the extension of Newton's second law. And now we have to study motion on horizontal and inclined surfaces and motion on connected bodies. the applications of D'Alembert's principle, so the problems. So today we will see the motion on horizontal surfaces, horizontal surface and motion on vertical direction also, a few problems. Totally 6 problems. So already 10 problems are over. So today we will have problem number 11 to 16. We will go on to the problems. So before, what are the steps involved for solving the problems on kinetics of rectilinear motion? Step 1. First step is to draw the free body diagram and kinematic diagram of the given source. Kinematic diagram means we are relating the inertia forces also. In addition to the forces acting on the system, we will draw the inertia forces also. That is why it is called kinetic diagram. Now step 2, resolve all the forces and inertia force. And step 3, apply the equation of motion and find the unknowns. Resolve the forces. Next, if the equations of motions or any parameters in the equations of motions is asked, apply equations of motions and find the unknowns. So these are the 3 steps. See, basically draw the free body diagram, write the kinetic equation F is equal to ma, resolve the forces. That's all. So problem number 11. A block weighing 1 kilonewton rests on a horizontal plane as shown in the figure. So this is the block. So this block has a weight of 1 kilonewton. This block has a weight, this block has a weight of 1 kilonewton. So this weight always acts downwards and it rests on a horizontal plane. So this is our horizontal plane. Find the force P required. So force P is applied in an inclined direction to give an acceleration. Acceleration is given as 3 meters per second square towards the right. So force is applied towards the right in an inclined direction. The force is inclined at an angle of 30 degree. Take the coefficient of friction, mu is equal to 0.25. So first of all, we will draw the free body diagram. Okay, so drawing the free body diagram. So this is 1 kilonewton. See, weight of the block is 1 kilonewton. So it is 1000 Newton weight of the block. Now it is resting on a horizontal plane. It is resting on a horizontal plane. So we have a normal force perpendicular to the horizontal plane. We have a normal force perpendicular to the horizontal plane. We have a frictional force acting opposite to the direction of motion perpendicular to the normal. That is, this is 90 degree. The angle between the normal force and the frictional force is 90 degree. Now frictional force is mu into n. Our value for mu is 0.25. So it is 0.25 into n, normal force. Now we have a force P. So this force P is resolved into 2 components, horizontal and vertical components. So horizontal component is P cos 30 and vertical component is P sin 30. You can see the direction. Horizontal direction is like this and the vertical direction is like this. Now we have to write the inertia force. That is, inertia force will act opposite to the direction of motion. So this is inertia force, F is equal to mass into acceleration. So now our free body diagram is over. Now we will apply the Newton's second law of motion. That is, sigma F is equal to ma, mass into acceleration. So applying Newton's law in the x and y direction. So sigma F is equal to ma. So sigma Fx is equal to ma. That is, force sigma Fx is equal to ma and sigma Fy is equal to ma. Now the motion is only on the horizontal plane, not on the vertical direction. So the inertia force on the vertical direction is equal to 0. Sigma Fy is equal to 0. We have the movement on the x direction. So sigma fx is equal to ma, mass into acceleration. So resolving the vertical forces, this n is equal to 1000 plus p sine 30, or n minus 1000 minus p sine 30. That will be our equation 1. And equation 2 is, we are resolving horizontally. So horizontal forces are p cos 30 minus 0.25 Newton is equal to, or minus ma. So here we can see p cos 30 minus 0.25 Newton minus ma. So we are taking it on the right. So that is equal to ma, mass into acceleration. So mass is 1000 divided by g. This is in Newton. So converting to mass is always expressed as kilogram. So 1000 divided by g. G is 9.81 into acceleration. So for acceleration, the value is given for us. Acceleration, the value is 3. 3 is our acceleration. So now we can resolve equations 1 and 2. We get the external force required to push the body is, to move the body is 750.056 Newton. Next problem. An elevator is required to lift a body of mass 65 kg. So weight of the body is 65 kg. Find the acceleration of the elevator. We are asked to find A, which could cause a pressure of 800 newtons on the floor. So the force is given as 800 Newton. See, an elevator is required to lift the body. The body is moved upwards. So this is the motion of the body. Therefore, our mass into acceleration will act in the downward direction. Mass into acceleration will act in the downward direction. Now, an elevator is required to lift the body of mass. Mass is 65. Find the acceleration of the elevator, which could cause a pressure of 800 newtons on the floor. So pressure on the floor is 800 Newton. So it will be in the upward direction. Now there is no inclined surface, no horizontal surface, no vertical surface. So there is no need of frictional force. Frictional force is not considered here because there is no surfaces. There is no surface of contact. Now, listen, this force, this 800 Newton pressure is applied on the floor to lift this 65 kilogram body. So we are asked to find what is A, what is acceleration. So we apply Newton's law in x and y direction. There is no forces in the x direction, so only y direction forces are there. So sigma Fy is equal to mass into acceleration because movement is in y direction. So we have mass into acceleration in y direction. That is 800, this 800 minus 65 kilograms. This is the force, so this should be in Newton. So it is 65 into 9.81. In order to converting this kilogram to Newton, is equal to mass into acceleration. Mass is 65 kilograms and acceleration. So the only unknown is acceleration. We get A is equal to 2.4969 meter per second square. Next problem, a body of mass 5 kilogram. So 5 kilogram is acting in the downward direction, starts from rest. So since it is starting from rest, okay, and attains a speed of 4 meter per second. So u is equal to 4 meter per second in a horizontal distance of 12 meter. So s is equal to 12 meter. Assume coefficient of friction mu is equal to 0.25. Mu is 0.25. What is the minimum value of force P may have to accomplish this? We need to find what is P. So now First of all, our aim is to find A. What is A? So it starts from rest and attains a speed of 4 meter per second. That is, u is equal to 0 and v is equal to 4 meter per second. So by substituting u is equal to 0 and v is equal to 4 meter per second, in the equation of motion, v square is equal to u square plus 2as, we get a is equal to 0.6667 meter per second square. Now, we can resolve this into a is known. So, now we can resolve the horizontal and vertical components. We get P is equal to 15.5955 Newton. So, free body diagram you can see there is in a horizontal distance. So, we have a horizontal plane. So, we have a normal force, we have a frictional force normal to the normal force. We have the acceleration in the direction opposite to that of motion. So, P is taken in the rightward direction. This mass into acceleration is taken in the leftward direction. Okay, the next problem is a block weighing 2500 Newton rests on a level horizontal plane for which the coefficient of friction is 0.20. This block is pulled by a force of 1000 Newton which is acting at an angle of 30 degree to the horizontal. Find the velocity of the block after it moves 30 meters starting from rest. So here the weight of the body is given. So from this weight you can find the mass of the body. So force is equal to mass into acceleration. So from that we will draw the free body diagrams. After drawing the free body diagram, you resolve the components. We will get A is equal to 1.044 meter per second square. Now after finding A, in the equation of motion V square is equal to u square plus 2as, u equal to 0. U equal to 0, S is equal to 30 meter, u means at initial velocity is taken as 0. S is equal to 30 meter, that is distance moved is 30 meter, acceleration is given for us. So we can find the velocity, final velocity. The velocity after the block has moved 30 meter is 7.917 meter per second. 15th problem, a mine cage weighs. So the body is a cage that weighs 12 kilonewton and carries a maximum load of 20 kilonewton. So total weight of the body acting downwards is 32 kilonewton. Total weight is 32 kilonewton. Now the average frictional resistance of the sliding guys is 500 Newton. So the moment is now vertical direction. So it is, listen, what constant cable tension is required? So what force is required? What tension is required to give a loaded cage an upward velocity? So moment is in the upward direction. So force is in upward direction. So T is taken in the upward direction. Automatically our frictional force will be taken in the downward direction. So 500 Newton frictional force is taken in the downward direction. It is given, see surface is not given, but in the problem it is given resistance of the slide guys, resistance of this cable. The frictional resistance of this cable is 500 Newton. So the frictional resistance is taken in the opposite direction to that of motion, it is 500 Newton. Now what constant cable tension is required to give a loaded cage an upward velocity of 3 meter per second. So velocity is 3 meter per second. Final velocity is 3 meter per second from a distance of 3 meters. So S is 3 meter. Initial velocity can be taken as 0 meter per second. Now by substituting these values in the equation of motion, we get A acceleration is equal to 1.5 meter per second square. Now we can resolve the free body diagram. We get T is equal to 37.392 kilonewton. So remember, convert kilonewton to Newton. So mass is taken as the total load, that is 32 into 1000 is for converting kilonewton to Newton, divided by 9.81, that is acceleration due to gravity. Next problem, last problem. A lift carries a weight of 1 kilonewton and it is moving with an uniform acceleration of 3 meter per second square. Calculate the tension in the cables when the lift is moving upwards and downwards. So very simple problem, only the vertical motion. You can easily draw the free body diagram, resolve it, and you can find the answer. So when the lift, two cases, so two free body diagrams, two conditions, you can solve the answer. Draw two free body diagrams. For the first case, draw a free body diagram. Find what is the tension in the cable requires when the lift is moved upwards. That is, your tension will be equal to, force will be equal to 1.305 kilonewton. For the second case, again draw the free body diagram, solve the equations. We get, for the downward motion, the tension is equal to, or the force is equal to 0.694 kilonewton. So hope you all understood, and I believe you can solve these 6 problems. Tomorrow we will see how to solve the problems on inclined surface, and if possible we will go on for connected bodies also. Otherwise we will see the connected bodies on the next class. Thank you.